In this video, we're going to talk about solving quadratic equations. A quadratic equation is sometimes called a second-degree equation, which means that the highest power on x is a 2. And solving with an x squared is different than solving with an equation where x is just to the first power. So I can't just move things around and get x by itself anymore. I need a new strategy. So we're going to look at 4 strategies in this video that you can use to solve a quadratic equation. Some of these you might have looked at before. Some of them may be new to you. All right, so 4 ways to solve. The first one is factoring. So we've talked already about factoring, but just to give you a quick review. To solve by factoring, I need to get 0 on one side of the equation. I'm going to do my factoring, and then I'm going to apply the 0 factor property, or the 0 product property. It has a couple different names. That's the part where we set each factor equal to 0 so that we can get all the possible solutions to the equation. All right, so let's try that out. So I could solve x squared minus 25 equals 0. I already have 0 on one side. So I could factor. This is a difference of 2 squares. So I'll have 1x plus, and 1 with a minus. Sorry, that's a minus sign right there. And then once I've done my factoring, I'm going to set each part equal to 0. And solve each of those. And that's going to give me 2 answers this time. If you want to be really fancy, you can write them in the squiggly brackets. So -5 and +5 are my 2 answers. All right, so that's the basic process. Let's try one more. What do I need to do first? I need to get 0 on one side. So I want to move this 5 over to the left. I'll subtract it over. Now I'm ready to factor. Two numbers that multiply to be 5 and 1, and add to be +4. If I make the 5 positive and the 1 negative, that'll work. At this point, I want to set each part equal to 0. And then solve both of those. That's going to give me 2 answers, +1 and -5. All right, so this is solving by factoring. That's one strategy, right, that we can use to solve something with an x squared. Okay, another strategy. This is also one we've looked at before. It's called the square root method. So the way the square root method works is we're going to isolate the squared term. That could be an x squared, or it could be a parentheses squared. We're going to get that part by itself, and then we can take the square root of both sides. Remember, when you take the square root of both sides, you want to make sure that you include a plus or minus. All right, so let's try that on this one. I know we just solved this one, so here's another option. you can isolate the squared term, which would be the x squared. So I'm going to move the 25 over to the other side. And then I'm going to take the square root of both sides. I'm going to make sure I put the plus or minus in there. Those are those two roots that we've talked about in the past. A square and a square root are opposite operations, so they cancel each other out. The square root of 25 is 5. So I'm going to get my same two answers, positive 5 and negative 5. Alright, I'm being fancy tonight with my squiggly brackets, but you can leave your answer just like this. That's totally fine also. Okay, let's try another one. This time we want to isolate the parentheses squared. So it would not be appropriate to take the square root of both sides right away. We need to remove this 10. So I'm going to divide, right now it's multiplied, so I'm going to do the opposite and divide both sides by 10. $50 divided by 10 is 5. And then I'm going to take the square root of both sides. The square and the square root are going to cancel each other out. I can't simplify the square root of 5. And because I want to give an exact answer, I'm going to leave the square root of 5 there. My last step, because I'm solving for x, is to add this 5 over to the other side. My final answer is going to look like 5 plus or minus the square root of 5. Okay, and this is a totally fine answer. Online, in your homework, they're going to ask you to break it up as 5 plus the square root of 5 and 5 minus the square root of 5. So just know that that's coming, right? Either of these would be good. Personally, I like this one better. Okay, either one is just as good. All right, I think I have one more. So this time we have x plus 1 squared plus 49 equals 0. So what do we need to do first? We need to get the parentheses squared by itself. So we need to subtract the 49 over to the other side. Now I'm ready to take the square root of both sides. Don't forget the plus or minus. The square and the square root are going to cancel each other out. What is the square root of negative 49? Yeah, 7i. It's negative, so I need a complex number. And then I'm going to move this 1 over to the other side. And when I have a complex number, remember I want to write it in that a plus bi format. So I get negative 1 plus or minus 7i. All right, the same thing's true here. I like this answer. This is totally fine. Online, they're going to ask you to break it up as negative 1 plus 7i and negative 1 minus 7i. So just be prepared for that. Okay, that's two methods. The third method is we could use the quadratic formula. So I usually use factoring as my first line of defense. Unless my equation is sort of in this format like this, where it's already been factored. Then I want to use the square root, right? The square root method kind of fits that special format. If it's not factorable and it's not already factored, if I just can't get the factoring to work, then this is my backup. All right, and this is probably the only formula I'll have you memorize this semester. I just feel like in algebra, you should walk away with this one memorized, right? It's kind of like a big part of algebra. Okay, so this is a formula that solves any quadratic equation. It works every single time, right? You could use this for all of yours if you wanted to. It's not as fast as factoring. I think factoring is faster. Sometimes factoring gives us more information than this, or at least faster information maybe. But this is a good tool. Okay, so let's try it out. I'll try it out on this one. For this one, remember a is in front of x squared, so that's 1. B is 2, and c is 3. The book got really creative on this one. All right, so we'll plug it into our formula. So we've got the opposite of b plus or minus the square root of b squared, so 2 squared, minus 4 times a, which is 1, times c, which is 3, all over 2a, where a is 1. So this will give us negative 2 plus or minus the square root of 4 minus 12 over 2. 4 minus 12, that would be negative 8. Okay, I should give you the warning I always give, right? Usually in these problems, if you remembered the formula, the first step looks really good. If you've made an error, it's somewhere between the first step and the last step. So you want to write out a couple lines and simplify carefully till you get to the bottom. Okay, we have a little bit more to do, right? The square root of negative 8. We want to break that down. We're combining a couple things together here, right? So I can break that up. 4 is a perfect square. If I take the square root of negative 4, that's going to give me a 2i. And then I have 1, 2 left over inside the square root. Can I put that right here? So that's going to be negative 2 plus or minus 2i times the square root of 2 over 2. Both of these pieces get divided by 2, the number out front and the number that I just brought out of the square root. So let me go right here. So that's going to give us negative, I'm going to break it up for you, negative 2 divided by 2 plus or minus 2i divided by 2 times the square root of 2. Lots of 2's, and we can cancel several things, right? So this is going to be negative 1 plus or minus, these 2's are going to cancel, right? So I square root of 2. I like to write the I in the front if I am working with a square root, but you can write it in the back. This is just my personal preference. All right, so you want to be able to use that quadratic formula. If you haven't practiced with it in a while, you want to go back and do a couple of these and make sure that you've got it. Okay, let's try one more. So this time we have 2x squared minus, this is like a negative 1x, minus 3. So we've got our a, b, and c. We're going to plug it into our formula. So we've got the opposite of b plus or minus the square root of b squared. This time b is negative, and I always recommend putting that b in parentheses so that you don't forget, because this is a place where a lot of people make a mistake, to square the negative as well. Okay, so negative 1 squared in parentheses minus 4 times a, which is 2, times c, which is negative 3. Sorry, I didn't leave myself enough space there. All over 2 times a, which is 2. This is going to give us 1 plus or minus the square root of 1. Notice I have 2 negatives here, minus and a negative 3, so that's going to be plus. 4 times 2 would be 8, times 3 would be 24, all over 4. So that's 1 plus or minus the square root of 25 over 4. And I don't know about you, but I'm starting to get excited because I know that's a perfect square, so this one's going to work out really nicely. So that's 1 plus or minus 5 over 4. If my square root simplifies to be a whole number or a nice even number, I want to go ahead and break this up and continue, right? So I have really 2 answers. Let me write them over here separately. I have 1 plus 5 over 4, which would be 6 over 4, or 3 over 2. And I have 1 minus 5 over 4, which would be negative 4 over 4, or negative 1. These would be my 2 answers. All right, I don't usually take a lot of time to discuss what's inside the square root here, but that's called the discriminant. So what's inside the square root kind of determines what kind of numbers we get as our answers. If the discriminant is a perfect square, then we're going to get 2, I want to say nice answers, but 2 rational numbers, right, that are either a whole number or a fraction, but nice, okay? If I get a negative number, like I did in the first example, right, I got a negative 8. If I get a negative under the square root, then I know I'm going to get a complex number. That's that I showing up. Or if I just get a non-perfect square, maybe it's not negative, maybe it's positive, I know I'm still going to have a square root in my answer because I won't be able to simplify it all the way. All right, so that's the quadratic formula. The last solving method is a method called completing the square. So this is a way to take this format and transform it into the vertex factored type format that we would need for the square root. So the idea is to create a perfect square like this parentheses squared and then solve it by the square root. Okay, so there are some steps to do that. So I've outlined them here. The first step is if the a is not 1, right? So if I don't have just x squared here, if I have 2x squared or anything else, I'm going to divide both sides of the equation by a. Then I'm going to move the constant term, that's the just plain number part here with no variable, over to the other side. Okay, once I've done that, on the left-hand side, I'm going to do LHS for left-hand side. I'm going to be left with x squared plus something x. Right? Technically it's not b, but I'm going to let it be b for the moment. Okay, and this is the part that I really want to turn into a perfect square. So I need to add a number here, right, to make it factorable into something that's a perfect square. So there's a lot of ways to do that. You can use the factoring. I'm going to show you how to think about the factoring. And there's a shortcut. So we're going to add an amount or a number to both sides. The shortcut is written here, right? I can take b, what number in front of x, divide it by 2, and square it. And whatever that number is, that's the number I want to add to both sides. Okay, and I'm going to show you that in just a second. I think it'll be a little more obvious where this is coming from. Okay, once we've done that, we added our number right here. Then we're going to factor that, and it should factor into a perfect square. That's kind of the point of this whole process, right? Okay, and then once we have our perfect square, we're going to solve with the square root method. So this really is like the setup for the square root method. Okay, so let's try this out. First step is we're going to divide both sides by a. This time a is 3. So we're going to divide both sides by 3. And we're going to get x squared minus 2x minus 4 equals 0. Then we're going to move the constant term to the right-hand side. This minus 4 is the constant term. So we're going to add 4 to both sides. Okay, and then we're going to leave a little space. So we'll have x squared minus 2x. We're going to leave a space, because the next step is to add a number to both sides. I always draw these little blanks so I don't forget to add it to the right-hand side. It's really easy to be focused on the left-hand side and forget about the right-hand side. Okay, so let me show you 2 ways to decide what number to put in this blank. One way is to think about how it's going to factor, right? I want to factor this into a perfect square, so I want these 2 parentheses to be equal. I know it's going to be x and x because of my x squared. I don't know what this last number is, but I need 2 numbers that are equal that add up to be -2. If they weren't equal, there could be a whole bunch of different options, but because they're equal, there's only one option. 2 equal numbers that add up to -2 must be -1 and -1, right? So the dividing it by 2 up here in the shortcut is because I want my parentheses to be equal, and they have to add up 2 equal numbers adding to this middle term. All right, then FOIL can tell us what this needs to be. So -1 times -1, or -1 squared, that's where the square comes from, gives me 1. And 1 is the number that I want to add to both sides. All right, so that is how to use factoring to reason it out. If you didn't want to do that, if you wanted to use the shortcut, the b here would be -2. So you would take -2 divided by 2 and square it. So that would be -1 squared, which is 1. And 1 is the number that we're adding to both sides. Okay? So we're adding it to the left and the right. We factored this. Let's go ahead and write it as x minus 1 squared. Okay, so that's really step 4. We did the factoring and we wrote it as a perfect square. The only thing left is to solve with the square root method. So we're going to take the square root of both sides. The The square and the square root are going to cancel each other out. And then to finish it off, we're going to add the 1 over to the other side. Okay, this is a process that takes some time to get used to. Some people really like this process. Once they've learned it, they do all their problems with this way. Completing the square does always work, just like the quadratic formula, but not every problem is going to have nice round numbers. That's good to know up front, right? Here, when I divided by 3, if this were not a multiple of 3, this could have been a fraction, which would have made this number interesting to find, right? And so it could trickle down and be kind of messy, but it will always work. I am not going to give you the messy ones. But if you decide to use this method for everything, you might come across some messy ones. Okay, so I have a couple more here for you to try. If you want to pause the video and try these out on your own, feel free to do that. I'm going to go through those same steps, right? So this time the A is 1, so I don't have to divide, but I do want to move the constant term over to the other side. I'm going to put in my blank. Okay, so I want to add a number to both sides. I like to use the factoring method because I feel like too many formulas to memorize sometimes. So I need 2 numbers in the back that are equal, that add to be -4. That has to be -2 and -2. Then using FOIL, -2 times -2 would be 4. Or use the shortcut. -4 is our B. We want to divide it by 2 and then square it. That's also going to give us 4. And that's the number that we're adding here and here. Okay, 9 plus 4 is 13. And I'm going to write this as a square. That's the completing the square part. Now I'm going to solve with the square root method. Don't forget the plus or minus when you do that. And then the last step is to add this 2 over to the other side. Okay, let's try one more. Same thing here, I have a 1 in front of the x squared, so I don't need to divide, but I am going to move my constant over to the other side. I'm going to put in my blanks. I'm going to factor. I need 2 equal numbers that add to be -6. -3 and -3 are going to work. -3 times -3 be 9. Or use the shortcut. It's also going to give you 9. 2 plus 9 is going to give us 11. I'm going to write this as a square. And then I'm going to finish solving by using the square root method. The last step then is to add this 3 over to the other side. Alright, I think on this test I usually make completing the square the bonus. So you'll see that maybe in there somewhere. I'm definitely going to give you some freedom to choose which method you would like as far as solving with an x squared. Some problems are better for factoring. They're quicker to do factoring. Some problems cannot be factored, and so the quadratic formula or completing the square is a good backup. Some equations are already in factored form, and then the square root method is really easy and efficient. So it is good to know when to use which method. So I hope this video helped you see how all the method works, all the methods work. And I hope you'll give it some time to practice each one. All right, well, good luck. We'll see you in the next video.